These are the complete answers to the quiz on 1-1 to 1-4. So in number 1, they wanted you to express the inequality in interval notation and graph the corresponding interval. It's not the graphing that I'm sure was the problem, it's the interval notation. So this is how interval notation works. Think about closed circles and open circles on number lines. Like when we graph this one, you put a closed circle at -1 and then the arrow goes off to the right forever. Closed circles equate to brackets in interval notation. And we start with -1 because that's kind of like our starting point. And then the second number is where we go to when we're going to the right. Except we're going to the right forever. So we put infinity there. Now, because infinity is forever, parentheses are kind of like your open circle, or you're going on forever. So here are some other examples of how interval notation works. If I were to give you something like -2 is less than x is less than or equal to 3, in interval notation that would be parentheses -2, comma 3 bracket, because the -2 would have an open circle and the 3 would have a closed circle. How about x is less than -4? Well, because when you graph this, there would be an open circle at -4 with an arrow pointing to the left. Since the graph goes to the left forever, we start with negative infinity. And then we put comma -4, and we use another parentheses. Again, parentheses are like your open circle, and brackets are like your closed circle. If you go to the right forever on a graph, infinity, positive infinity, will be the second term in what looks like an ordered pair. And if you have a graph that if you drew it would go to the left forever, you would start with negative infinity. The way that I dealt with 2a was I started by breaking down 96 into prime factorization. I like to use prime numbers, so I noticed it was an even number, so I kept dividing it by 2. So first I get 2 and 48, which breaks down into 2 and 24, which breaks down into 2 and 12, which breaks down into 2 and 6, which breaks down into 2 and 3. A fifth root says, can you take out a group of 5 of the same number? Well, I want you to notice there are 5 2's. So we're going to take out a 2. But I can't take out the 3 because there aren't 5 of them, so I'm left with the fifth root of 3. Well, now I want you to notice that these radicals are like terms. Radicals work like variables, where if you have the same root index and the same thing under the radical, you just add their coefficients. And I end up with 3, fifth root of 3. I can't tell you there's one right way of attacking this particular problem. I'll show you how I did it, but there are other ways of getting to the same answer. We want to use the properties of exponents. And which properties do you use first? Well, you can simplify what's inside the parentheses first, and then raise it all to the -3rd power. I happen to like raising everything to the -3rd power and then going back and simplifying the like terms. When you have a power on the outside of parentheses, you're going to distribute it to every factor in the parentheses. The way that property of exponents works is you multiply the exponents. So I'm going to get x to the -3rd, y to the +6, z to the +9, because that's what I get when I multiply the exponents together. And in the denominator, I'm going to get x to the -6th, y to the -9th, and z to the +12th. So now I've dealt with the -3. Now I'm going to simplify these. When you have like terms being divided, the property of exponents says to subtract them. So be very careful the order of subtraction. It's always numerator minus denominator. So -3 minus -6 is going to be +3. 6 minus -9 is positive 15. And then 9 minus 12 is negative 3, but we don't like negative exponents. We move it to the denominator and it becomes positive. Because we have a property of exponents that says a to the negative mth power is the same as 1 over a to the m. This problem gets students every time, and it's kind of depressing. I know you want to distribute the power 2, so you want to make it 4x squared plus 9y squared. It's just not. You have to write this twice. You have to write 2x plus 3y, 2x plus 3y, because squaring means multiplying it by itself. And then you have to FOIL it. 4x squared plus 6xy plus 6xy plus 9y squared. The middle terms are like terms. They combine, and they become 12xy. (4a) is one of our most common types of factors. It's called the difference of two squares. When you subtract two items, and they are both perfect squares, when you factor them, you take the square root of each. And in one of the parentheses, you get a plus sign, and the other, you get a minus sign. The reason that happens is because if you go to this line here, and you multiply it out, the middle terms will always be opposites and cancel, in which case you're just left with x squared, or a squared minus b squared. So, this is the square of 3a, and this is the square of 4. So in factored form, it's 3a plus 4, 3a minus 4. And I'll just put b down here. Not everything can be factored that way. When you're factoring, you should always look first for greatest common factors. Now, I didn't look for greatest common factor up here, but it doesn't matter. 9 is an odd number, 16 is an even number. They don't have a greatest common factor. But in B, you'll notice that all three of these terms share an x in common, 1x, and they all share 1y. Now, greatest common factor means you're going to divide everything by that term. Well, when you divide it and you use your property of exponents, the first term is left with 2x. The second term is left with minus 6y, and the third term is just left with 3. And that's all you can do to that problem. For problem number 5, in order to simplify this, you needed to first factor the numerator and denominator. These are both simple trinomials. You know, they're the ones where you look for two numbers that multiply to give you the last term, but those same two numbers add to give you the middle term. Well, x squared plus 6x plus 8 is going to factor into x plus 2, x plus 4, because 2 times 4 is 8, and 2 plus 4 is 6. The two numbers that multiply to give you 4, but when you add them you get 5, are 1 and 4. Well, now that it's in factored form, if I have a common factor in the numerator and denominator, they cancel, and I'm left with x plus 2 over x plus 1. One of the things we did, probably towards the end of the year last year, was talked about adding and subtracting rational expressions. Well, adding and subtracting fractions can only occur when the denominators are the same. So what do you do if the denominators aren't the same? Well, this has an x plus 5 and this has an x minus 3. A lot of times, the least common denominator is just the product of the two. So I want both of the denominators to say x plus 5 times x minus 3. That means this first fraction needs an x minus 3 in both the numerator and denominator. And the second fraction needs an x plus 5. So now what I'm going to do is I'm going to multiply out the numerators because I just made the denominators the same. X minus 3 times 1 is just x minus 3. And then I'm going to add that to 2 times x plus 5, which is 2x plus 10. And I like to leave the denominator like this. Well, I'd still have to simplify the numerator. I have 3x plus 7. And I can't do anything further with that. And so this is the sum of those two fractions. If you really want to multiply out the denominator, you can, but you don't have to because this answer is acceptable. In calculus, we don't do a lot of rationalizing the denominator. However, we do often rationalize the numerator. The process is the same, which is why this particular problem is important. In order to rationalize the denominator, you want to get rid of that radical 3. Well, to get rid of it, we're going to multiply by something called the conjugate of the denominator. The conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. The reason these are called conjugates is because when you multiply the denominators together using FOIL, the middle terms are going to be opposites and cancel. So when you multiply fractions, you always multiply the numerators. 1 times anything is anything. And the denominators are going to be 4 plus 2 to the square root of 3 minus 2 to the square root of 3 minus the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. So what ends up happening is the middle terms will always cancel. And the radical will go away because when you multiply a radical times itself, it's the same as squaring. So you're left with 4 minus 3 in the denominator, which is 1. So you can either write it over 1, or we usually just write the answer like this. So now your job is to go back and any problems you had difficulty with that you did not get right, you can get the points back by simply doing the problems I gave you on the sheet. You can always go back and rewatch videos from Chapter 1. They are all posted on both Educreations and on YouTube if you're having internet troubles at home.